this quick. Here with the odd numbers. Here we go. So we have ½ inch is the same as 4 feet. And then if you want to change it to a decimal, that's fine. This is 2½ inches equals, x feet. You can cross multiply if you want. It's up to you. The 8th grade teachers actually want you to cross multiply, so listen to them. So that's ½ feet, half of x, and then 2½ times 4. That's 10. You can divide this by half and divide this by half, right? So x equals 20. Okay, so the actual height of the pole is 20. 3. Again, type mark at 82 feet high. For a science project, it would be a scale model to block it. So how tall would be the model if you use 1 inch? This particular scale, so 1 inch is 5 feet. We want to know if it's 82 feet, how many inches will it be? So there's my x right here. Again, cross multiply, so we got 82 over here. 5 times x is 5x. Divide both sides by 5, and I have an idea. That goes away, and let's divide 82 by 5. 1, 8, sorry, 1, 5, 32. It's going to be 16.4. Would be the height of his model. Okay. 5. Okay, so very procedural today, right? Again, 1 inch equals 2 2/7 feet. And pants of the military, there's a dollhouse. Okay, 1 inch represents 2 2/7 feet in real life. Pants of the military uniform of the father in the dollhouse is 1 2/5 inches long. So how long would the pants be in real life? So cross multiply, we got x. And then multiply 1 2/5 times 2 2/7. Let's multiply that. So that's 7 over 5 times 14, 16 over 7. So 16 over 5 or 3 1/5 feet. Okay. So now we're doing 6. I think I'm going to pick the odd numbers. Max scale drawing between Salt Lake and Arizona. Distance. Alright, so I'll put Salt Lake over here. Arizona over here. This is on the map. It's 21 centimeters. Right? We have our scale. 7 centimeters equals 250 kilometers. In real life, how much is this 21 centimeter represent? So I'm going to put 21 centimeter equals to x kilometers, right? So you can simplify this if you want. Right, 7 over 21, you can break that and make it 1 over 30 if you wanted to. And then 3 times 7, 250, 750 kilometers. In real life, if you didn't simplify, you would multiply 7 times x, which is 7x. 3 times 250. No, sorry, 21 times 250, and then divide everything by 7. Okay, you get the same answer. 9. Scale drawing. There's a room. So this one, quite a few of you asked a couple of questions. So there's a room on my drawing, and in my drawing, this measures 6 centimeters, and this measures 7 centimeters. So if I were to ask you the area of this, you can find it. It's 6 times 7, 42 centimeters squared. Now imagine a real life bedroom, right? So if you want the actual dimensions of the room, the real life room, we're going to use this scale. And we're going to have to find out what 6 centimeters represents in real life and 7 centimeters represents in real life. So 5 centimeters, 10 feet, or if you want to simplify that, we wrote 1 centimeters equals 2 feet. Totally fine. So we want 6 centimeters equals how many feet? So x equals 12 feet. So in real life, that width here is 12 feet. Let's do it again for the 7, right? So 1 centimeter equals 2 feet. That's our scale. 7 centimeters is in real life, and that represents x equals 14 feet. So this is 14 feet. Now we're not done yet because they want the area, right? Well, they want the area? No, they just want the actual dimension. So Andrew's office is a 12 feet by 14 feet office, and if you wanted to find the area, you multiply 12 times 14. But they're not asking that. Scale, 1 centimeter equals 5 kilometers. They're asking as if in real life it's 14 kilometers. How many centimeters would that be in real life? So I'll put X in here. Cross multiply. We get 14 equals 5x. Divide both sides by 5. X equals 5, yeah. 2, 10, 2.8. 2.8 centimeters. (13) we have a scale drawing, basketball court 1 inch. Go straight to the proportion, is 9 feet. The free load is 15 feet from the board, so how far is the back of the board in the drawing? So we're trying to figure out in the drawing how far it is. So again, you could have simplified this. I'm not. So 9x, right, cross multiply. 15, eventually going to simplify now. X equals, divided by 3 is 5, divided by 3 is 3, x equals 1 and 2/3 of a foot. In the drawing, that's where the backboard would be. 15, fractions of decimals, your choice, half an inch, 3 centimeters. The actual length of the coffee mug is 4 inches. So in centimeters, how much would that be? X centimeters. We get half of x is 12. Both sides by half. X equals 24. 24 centimeters. 17. Okay, so 7 inches. So right off the bat, I look for the scale. It says 7 inches is 15 feet. So I can start writing my proportions. What equation represents the relationship between the actual height in x and feet in the height of the model y? So 7 inches represent the actual height. The actual height is x. So So if you do this, this would be the height of the model. And here is my y. We'll write height of the what? Height of the actual height is your x-axis. Okay, and we know 7 inches. Built a model 7 inches to represent, so we have a point here which is 15.7, right? So the actual comes first and the model comes second, because the actual is your x-axis. So point 15.7 is right here. I'm just making it up, 15 and up, so 15 to the right and up 7. Let's just write 15.7. So if the relationship is proportional, can we find k? K is 7 over 15. Right? Sorry, it looks like an x. Sorry. Let me write that again. K is proportional, right? So k is y over x. We have a point. And k equals 7 over 15. Okay? That becomes my unit rate, right? My unit rate. Sorry, not my unit. You can simplify that. But we're not going to do it. So the equation is 7 over 15 x. They're not asking for the unit rate, okay, so we're okay there. Sorry, take that back. So when x equals 1, when x equals 1, what is y? Y equals 7 over 15, right? So that would be our unit rate. Okay. Write that point over here was 1, and this is 7 over 15. That'd be really great. They're not asking for it, so. 19, the floor plan of the house, 3 centimeters. Little room. 3 centimeters is 4.5 meters. Find the actual length of the room if on the drawing the living room is 5 centimeters. Again, like I said, very repetitive. So we get 3x equals 5 times 4.5. We get 25, 22.5. Both sides by 3, and x equals whatever that is. 7, 21, 7.5. X is 7.5. 21, 2/3 of an inch is 8 feet. Basement is 2.5 inches. How much is that in feet? Alright, so are we going to get 2/3 x cross multiply? 2.5 times 8, which is 20. Okay, and then we're going to divide both sides by 2/3. X equals 20 times 3 over 2, which is 90, 45, sorry, 60. 60, 20 times 3 is, or we can simplify, 20 times 3 is 60, divided by 2 is 30, so we get 30, what is it, 30 feet. Okay, is that right? All right, the other one, this one, and we only had 4 questions, so question 12 was a mess. I'll fix it in a second. Well, the first question is asking why the side lengths are proportional, so these two triangles are similar, quite wildly similar. What is the scale factor going from STU, so we're going from this to this, so it's a scale factor, it's a reduction. Right? And we gotta pick, you got 4 sides here. So VS is 3, TU is 6, VU is 9. ZY is 3. ZW is 1. What? ZW is 1. Oh, sorry. Wrong one. ZY is 3, ZW is 1, and XY is 2. So, with the corresponding side, let's pick the easy one. VS is 3. Z. Okay, so, how did these, so for example, how did this side become 1? How did this side becomes 3, right? And how did that 6 become 2? So you can obviously tell it's a reduction, right? So pick any other corresponding sides. Let's pick one with a 3. So 3 became 1. So if it's a reduction, it's the small one over the large one. So your scale factor is 1/3. And if you did any other one, let's use this one, XY here, 2, and then it matches up with 6. It's still 1/3. So it doesn't matter which corresponding size you used. Reduction, every side was multiplied by 1/3. Hexagon, same thing. What is this? Turn the scale factor from the smaller to the, so okay, we're going to get a number greater than 1. The large one has a period of 48. There's 1, 2, 3, 4, 5, 6. So 48 divided by 6 is 8, which means every side here is 8. The smaller has a perimeter of 12. 12 divided by 6 means every side is 2, right? They're all the same. So this is a scale factor. It's where we're going from the smaller to the greater. So it's an enlargement. We're going to do the big one, 8 over 2, and the scale factor is 4. Okay. So this one, very messy. I think, let's see how I fix this. this patio, so I made this the drawing. If the drawing has dimensions 5.5 by 7, and the actual patio has dimensions of 500, 700, what is the scale factor from the drawing to the actual? So let's do the small one. This small one, this is 5.5. This is 7 centimeters. In real life, that patio, right, has dimensions 550, and this is 700. Right, so what was the multiplier, right? What was the scale factor? So definitely an enlargement. Right? The scale factor, doesn't matter who you pick. So let's pick 700. And over 7, the scale factor is 100. So it's 100 times bigger, right? All the sides. Oh, and then two rectangles have proportional side lengths, okay. Here the rectangle A, which I believe this, is 40 centimeter, and side P is 8. So if this is 8, and the area is 40, obviously Q is 5, right? Because 8 times 5 is 40 centimeters squared. Right? And then the area of the triangle B is 1.6 centimeters squared, and the side S measures 1.6, which means this point, this one R measures 1, right? Because the area is these two sides, the length times width. In order to get 1.6, this has to be 9. So, what is the scale factor for not triangle A? So let's call quadrilateral A to quadrilateral B. Obviously, if you're going this way, it's a reduction, right? So, pick any side. Obviously, pick the easier side. So if it's a reduction, it is 1, right? This side over this side. So that's 1/8. So everything was multiplied 1/8 by 1/8 to get 1.6 in one. Right, so 8 times 1/8 is 1. 5 times 1/8 is 1.6. And that's sort of scale factor here. It's a reduction, sorry. And it's 1/8. Okay, that's it.